This is your invitation to leap ahead in your engineering career. The inaugural Product Development Expo, PDX, happening in Phoenix, Arizona on Tuesday, May 14th, 2024, brings you face-to-face with the engineering elite. These aren't just any speakers, they're the industry's highest performing product development engineers, ready to share the methods and strategies that have defined their success. Imagine learning design for manufacturability from those who've redefined it, diving deep into tolerance analysis with pioneers, exploring novel engineering applications for Excel, and unlocking unique 3D printing strategies all in one place. These high-caliber engineers will open their playbooks, offering practical, hands-on lessons forged over decades in the trenches of innovation. Don't miss out on this unparalleled opportunity to absorb the wisdom of those who've led the charge in engineering breakthroughs. PDX is your chance to not just meet but learn directly from these legends of engineering. Mark the date, May 14th, 2024, in Phoenix. Elevate your skills, ignite your creativity, and join a community of growth-minded engineering professionals at PDX. Learn more at teampipeline.us/PDX. And enjoy today's episode featuring Joe Moak, one of our esteemed PDX presenters.
So the trick that I have found is, again, through that prioritization, figure out what it is about this product that really matters most to customers, and then figure out who you need to bring in or what expertise you need on the team. Do you have it on the team? If you do, great. If not, go find it.
Hello and welcome to the Being an Engineer podcast. Our guest today is Joe Moak, who holds a degree in mechanical engineering from Cal Poly. Joe also worked at a plethora of high-profile OEM and product development companies such as St. Jude Medical, Sonos, and Apple, and is currently the founder and chief engineer at Maestro PD, a product design and engineering firm that helps deliver premium quality hardware products to market. Joe, thank you so much for being with us today.
Thanks for having me.
Okay, first question, what made you decide to become an engineer?
It's a great question. It was the Sony Sports Handycam.
Oh, that's so specific. I love it.
Very specific. In about 1986, I remember our family saved a bunch of money. My brothers and I loved riding motorcycles. And we had our eye on the video cameras for a long time. And that Sony Sports Handycam just, checked all the boxes. Durable, sturdy, waterproof. We could take it out in the woods with us, out to the motocross track. And I remember the first time I got my hands on that thing and saw all of the latches and the seals and, the shiny finishes on the plastic and the matte finishes on all of the interface elements. There was a motor that ejected the tape. It was just an incredible piece of kit. And I was, I think, 12 at the time. And I remember thinking, man, that was a time when this thing didn't exist, but it exists now. And humans had to have been involved in the creation of this thing. And when I grow up, I want to make stuff that's as cool as this.
That's such a great story. I'm so impressed that at 12 years old, you had the depth of thought to realize that. Were you a very contemplative youth growing up?
I don't know that I'd go that far. But I did spend we grew up in rural Oregon. I lived a mile up a dirt road. My dad was a log truck driver. There was always a lot of broken heavy machinery around, lots of tools. I learned to weld about the same time we got that Handycam at about the age of 12. So yeah, I've always spent a lot of time tinkering with the matter that's in front of me.
Nice. That sounds a lot to me. I know it wasn't a farm, or I guess I don't know that. Maybe it was, but it sounds a lot like the description of a farm with, machinery all around and welding. And I hear so many stories from people who grew up on farms about it was the best preparation for becoming an engineer, because constantly there were problems to solve and tools to solve those problems.
Absolutely. Yeah. Yeah. If there's a second influence, it's MacGyver.
I love MacGyver. What a fantastic show. I remember the first one I ever watched even. What a great show. I'm so thankful that you brought that up. It's just bringing back all these memories now. Well, I have a question for you about Cal Poly. Their motto, at least now, is learn by doing, which I absolutely love. Was that their motto back when you attended the university?
Yeah. And Cal Poly was it. There was no backup.
No backup. Okay. Yeah. Tell me a little bit about that. What made you decide to go to Cal Poly? And also, I'd love to hear about how they incorporated that motto into the curriculum. Sure.
Oh man, great question. It's been a long time. For those of you who are not watching the video, there's enough gray in my beard that I'm talking about the gray in my beard because I'm stalling, running the query on the database.
Lots of wisdom.
The curriculum was, now that I've been around a while and I've worked with a lot of people from a lot of different schools, I think that the fundamental engineering curriculum is very similar. The way that they brought in sort of the by doing part is there was still a lot of time in the lab. So there was a lot of, here are the formulas. And now we're going into the thermal lab. And here are the things that actually get hot. Here are the thermometers. Here are the chambers. And you're going to actually take measurements. And there was a lot of sort of correlating the empirical evidence with the theoretical calculations. And there was a lot of building.
Oh, great.
I built a bicycle. I built a robot, among, many other things.
That's fantastic.
Yeah, the labs were good. The shop was cool.
Hearing you talk about labs it reminded me of an experience I had when I was in college, and I was in a lab. I think it was a heat tran class, and we had a lab for it. And the instructions for doing this lab exercise kept talking about this thermometer, and I was like, thermometer? What is a thermometer? And my group's like, thermometer.
Yeah.
Anyway, neither here nor there. Okay, Maestro helps clients deliver premium quality hardware products. Not just hardware products, but premium quality hardware products. What is a premium hardware product? And conversely, what's an example of a hardware product that you wouldn't consider to be premium?
Oh, yeah, that's a great question. It may be a bit of a made up word, but when I think of premium, and the reason I use that word is the idea I'm trying to get across is, we pay a lot of attention to the experiences that the products deliver to customers. And there's an experience. When you say the word premium, you're setting expectations that the object, the device, the product that you're going to interact with has some niceties that may be unexpected. Maybe it's a level of performance. Maybe it's a level of fit and finish. The big idea behind that word premium is that we care a lot about the customer and how they interact with the product. And there are things that designers and engineers can do in the design and development of a product to really elevate that experience. And then there are things that designers and engineers can do to detract from that experience. And, we continually strive to apply engineering rigor to those touch points that we know are going to be important and resonate with customers. When working with startups, it's really important to not over-index on features that, maybe some people or some beliefs push you to apply engineering rigor to that might not matter, right? So anyway, that's the big idea behind premium. It's the things that customers care about. And it doesn't necessarily always mean high cost. It just means that we're paying attention to those important details.
Have you found it challenging at all to differentiate yourself as a premium service firm? Because it feels like everyone these days is claiming that, yeah, our widget, our service, we're premium. This is the platinum level here, and the word has almost lost its meaning because everyone is claiming to be premium or platinum. What have you been able to do to really differentiate your firm as truly like we pay attention to this stuff? We spend a lot of time looking at these items.
Yeah. We talk about the specifics of those customer touch points. And then, honestly, there's nothing like a portfolio piece sitting in front of you where you can bring out the parts, you can bring out the products and say, many other organizations would choose to ignore some of these details. When you choose to embrace these details and understand that your customers might actually interact with this product and experience these details, here is how they might resolve and how they resolve differently when you pay this level of attention and care and execution. And you just compare that to a product where, that type of attention hasn't been applied.
Can you think of a product or a project where maybe you had the opportunity to kind of gloss over one of these premium touch points, but you didn't? You decided, okay, this is one of those features that's going to make the product premium. So let's spend the time and let's really work this out and figure out that feature. Can you think of any examples of that?
On the first Apple TV, there's where the bottom cover intersects the aluminum ring on the outside. If you look underneath, there's a form on the sheet metal that tucks underneath a lip on the inside, underside of the Apple TV. And we used a form cutter that was the same shape as the bend on the sheet metal right at the point that it intersected the ring, so that when you tucked the sheet metal into the slot, as the cutter pulled away, it left behind a surface that matched the sheet metal that tucked inside. Oh man,
that's so great. I just got chills listening to that. I love it. Okay, this is cool for a few reasons. First of all, I have a first gen Apple TV, and I'm going to go take a look at that now. And second of all, I don't know if I call myself a fanboy for Apple, but I really do like their products. I have a bunch of Apple gear. I actually don't have any of the iMacs. I know that was something that you worked on. No offense. I like my PCs as well. But, the iPad, the iPhone, the AirPods, I can't wait to get some of the what are the Air trackers that they just came out with? Air tags, that's what it's called. Air tags,
yeah.
Yeah, very cool. So if you don't mind, I'd love to spend a few minutes just talking a little bit about your experience working at Apple.
Sure.
Okay, so you were there for, I guess, close to 7 years, contributing on all sorts of products from the iMac, the Mac Mini, iPad, Apple TV. What, if anything, do you miss about working at Apple?
There are a few things. The easiest thing, like the first thing that comes to mind, is the people. Very few organizations have that sort of concentration of really passionate, really talented, really intelligent people working their tails off. On
premium quality people working on premium quality products.
It's cliche as it sounds. Man, there are not a lot of jokers around there.
Wow.
And you got to bring your A game every day. Yeah,
that's awesome. How does Apple cultivate such a high quality team?
When I was there, it was sort of from the top. Steve and Johnny were running the show. Man, those two guys are just incredibly talented, incredibly capable, and they had a really good sense for what was possible. With regards to technology and manufacturing and marketing, messaging. And I feel like there's sort of a personality type that kind of gravitates toward that kind of a challenge. And, the bar was just set really high. I felt like I had to work my tail off to keep up with a lot of the folk there.
How did they communicate expectations to the team? Like how do you, I mean, now you kind of know because Apple's a huge thing, but it was kind of in the earlier days of Apple back then. And how did people know coming in that the really high bar is what is expected of me?
My first experience with that happened in the interview process.
Okay.
And without giving anything away, the questions that they asked me were pretty in depth, pretty challenging.
From a technical standpoint?
Yeah, from absolutely technical standpoint for sure. I remember distinctly my interview with John Turnus, who was a manager at the time. He's now VP of hardware. He drew a problem up on the wall and, gave me the challenge. And I said, okay, well, here are the ways that you could solve it. And I was coming from a place where my boss was always telling me, okay, Joe, that's good enough. Like pencils down, just, ship it. And so I got to a point in this process where I'm like, okay, well, the answer is about like this. And he's like, okay, what next? And I'm like, oh, you mean I get to keep going? Like you want me to like do the calculation? And he's like, yeah.
Wow.
Like, oh, okay, great. And so I started doing the calculation. Yeah. And I'm like, holy smoke, man, if we get to apply this level of rigor to these, seemingly nebulous and fluffy interaction points, like this is going to be a fun job.
Yeah.
So that was my first exposure. And then, on the inside, it's almost, it's been a while. My memories that are coming back there, it's more sort of like tribal, kind of like a teamwork type of mentality, kind of driving everyone to achieve as opposed to, some, traditional carrot or stick. Yeah. It's more like, oh yeah, like we're all going to make this thing that's like going to be the best of this thing that's ever been made. No one's seen a tablet before. That's
people
awesome.
Are like, let's just go to see a really great product as opposed to, I hope I get my quarterly bonus or, that sort of thing.
I didn't see much of, or if any of that at all. Yeah. It was, wow. How awesome were you able to design that thing? How great did the parts come out? What tricks did you do with the injection molding to achieve these really aggressive goals?
Very cool. This is a total starstruck question here, but did you have any experiences with Steve Jobs or Johnny Ive?
Yeah. Just a little bit with Steve, but yeah, pretty close with Johnny. In that, he was the ID exec, and we were doing weekly or biweekly reviews. We worked through all of the details that were under investigation, and we'd present them to Johnny and say, all right, here's what you asked for. Here's how we can achieve that, or here's how we can't achieve it. Here are the things that we're doing to try to achieve those goals.
Were there things that they did as leaders, or maybe things that they didn't do that really helped the teams excel and be their best?
I would guess that each engineer would probably answer that question a little bit differently. What's coming to mind for me is, again, it's like the team and sort of the, we're all in this together mentality. When I showed up, man, I thought that I knew engineering pretty well, and I understood design a little bit, and then now I realize I knew just a little bit about engineering. I didn't understand design at all. And, I've been in the room where designers have looked at a part and the designers have come up with the tooling solution, and and all the engineers in the room just kind of shake their heads and they're like, oh man, that'll actually, yeah.
We just lost to the designers.
That'll work. No, I mean, at that point I'm glad that they're in the room, Yeah.
Yeah.
I don't know if I answered your question, but that's what's coming to mind for me.
that brings up the next question I wanted to ask you, which is what did you learn at Apple that's been useful in your subsequent engineering roles?
Really good question. I think the biggest thing that I took away from it is that as a design engineer, we spend a lot of time looking at CAD on the screen, spend a lot of time looking at prototype parts and sort of vetting our design through prototyping. It's a pretty standard process. In high volume production, I started to think of my parts as like really terrible pieces of clay. That's just kind of how I conceptualize it. Nothing's flat, nothing's straight. None of the geometry is as resolved as I'd like it to be. And I've started to imagine these sort of tolerance clouds around all of my surfaces. And I've implemented some CAD practices that kind of help me in early architecture stages, prioritize feature sets, prioritize assembly, so I can start to, I can predict manufacturing yield when I'm developing architectures. Try to get it, down to that fundamental level of refinement at the architecture level. Tolerance analysis is an incredibly helpful tool, as is finite element analysis. If you've got, certainly structural concerns, your parts, in addition to never being plumb level or square, they're also never infinitely stiff. They're all flexible to some extent. And I've been really surprised about the metal parts that have moved in assembly.
Really?
I think, this thing is going to be super stiff. Well, it turns out if you stack up, 3 other layers and then bolt them all together, like the metal might actually move, and it might actually detune an antenna, or it might create a discontinuity in a surface that reflects light in an unfavorable way, and now it looks unflat when it should be flat. Or all kinds of little things that can happen. So anyway, that idea of, even though it looks clean on the screen and this machine prototype works really well, when we start making millions of these things, they're all going to be just a little bit different.
You talked a little bit about some strategies that you use architecting at the beginning of your project, even within CAD. What CAD are you using?
NX.
NX. Okay. What can you touch on some of those strategies that you use to help keep things organized and ensure your tolerances are where they should be? Yeah.
It's for me, it comes down to priorities. I fundamentally, on most projects, I engineer the product 2 ways to start. I'll sort of outside in. If we have an ID proposition, I'll start by prioritizing all of the visible interfaces, and I'll try to fit everything inside, and I'll try to engineer all of my datum interfaces so that I'm minimizing the visible variation in gaps and offsets and any other alignments that are important. Icons to LEDs, connectors to connector openings, whatever those touch points are, I try to make those the first priority. And I ask myself, okay, well, if I care about this reveal between these 2 parts that customers are going to see, what are the mechanical features that I can engineer into these 2 parts so that when I put them together, the variation in gap and the variation in offset is as small as it can possibly be. So that's thing 1. And then thing 2 or design process 2 is outside in. When we actually stack up the real technologies that are required to deliver these features to the customer, how much room do they take up?
Yeah.
And where do the big pieces have to live? And how can we reconcile this technological requirement with these ID goals?
All right, I'm going to take a very short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. And speaking of pipeline, we started out, 12 years ago, something like that, as a general product design company. And one thing I always found challenging about such a business model is it takes a long time to get really good at all the different disciplines required to run an effective PD company, right? You have industrial design and electronics and engineering and understanding supply chain, designing for plastic injection molding and metal machining and sheet metal. There's just so many different disciplines that you really have to know to be successful in that model, versus just specializing in one thing that you can do over and over and over and get really good at much more quickly. Do you ever find this to be the case? And have you found it to be more effective to have several kind of like jacks of all trades on your team, or a few specialists on your team in, the different areas of product development?
Yes, and yes. It's super hard. It's super hard. I often feel like I end up being part 3D real estate agent and part therapist.
Tell me more about both of those.
When we're engineering, designing products, all of the cross-functional team members need some amount of volume inside the product. Electrical engineers need board space and component height. Antenna RF engineers need place for their antennas. Acoustic engineers need back volume and open area. Thermal engineers, if you're lucky enough to have one, they're going to want metal or graphite for spreading heat. They're going to want fins. They're going to want a blower. They're going to want open area and minimum gap. Like, they're just all of these different groups that have a stake in the product. And through most of my career, it's been me and my team who own the master CAD files. And, on paper, our deliverable is 3D CAD and 2D drawings. In order to develop that 3D CAD and 2D drawing package to a point that when all of the parts are manufactured to those specifications and put together, you have premium product coming off of the line. It's just an incredibly intense, iterative process with every single one of those cross-functional teams. So yes, anytime we can bring in subject matter experts on the key touch points on the product, it's super important. One of the interesting things about working at Apple is we had subject matter experts for anything. If you name a thing, like, we could either find the best or engineer the best instantiation of that thing at that point in time. Which was really cool. Now, as a consultancy, we don't have those resources, not all of the resources available. So the trick that I have found is, again, through that prioritization, figure out what it is about this product that really matters most to customers, and then figure out who you need to bring in or what expertise you need on the team. Do you have it on the team? If you do, great. If not, go find it.
Great advice. What has been your favorite place to work, and why? Oh, I'm just going to say Maestro because I built it. That's fair. Yeah,
I built it so that it would be my favorite place.
And what elements of designing Maestro were intentionally incorporated to fulfill that desire of it being the best place that you could work?
Oh man, there are a lot of things. Number one was recruiting. We were able to bring in a lot of really great talent, not just engineering talent, design talent, and project management talent. Our space, we have a 3,200 square foot warehouse. 500 square feet of it is dedicated shop. So the layout of the place is a bit interesting. All of our desks are like early 20th century kind of sheet metal engineering desks, kind of steel case tanker style.
Yeah.
The interior is all OSB. It's just sanded OSB, which works really nice. It's inexpensive, number one. So when you're a bootstrap consultancy, that works nice. And it kind of looks cool.
This really gets into the minutia here. We are more than likely going to be moving into a bigger space in the near future. And I wonder how people organize their spaces. Tell me, how are your desks placed? Like, do you have, I don't know, 2 desks up against each other with people on either side so they're kind of facing each other? Or are the desks spread out like facing the walls around the bullpen area? How do you arrange that?
Great question. Our desks were in a grid in the middle of a large room with actually quite a bit of space around each desk. And the wall was behind us and the open design space is out in front of us.
Okay.
So everyone sitting at their desk is sort of, looking up and seeing the room, seeing the open space.
And is it like a classroom where everyone is pointed in facing the same direction, or different people facing different directions?
Yeah, everybody's desks are facing in the same direction. Though at any point during the day, it's I guess pre-COVID times, it was rare to have everybody actually in their seat at the same time doing work.
Yeah.
There was always something happening in the shop, always a meeting happening in one of the conference rooms. My brother built us this super sweet live edge table with blue epoxy down the middle, Siberian walnut that's right in the middle of the room, up near the whiteboard. We call it the design review table. I find that's incredibly helpful. Just having an open space with a clean table with a whiteboard next to it, incredibly useful. We also have a TV on an A-frame roller that we roll around. It goes into the shop,
cool.
Goes into the design review room, it goes into the conference room. Yeah.
And you can just like cast onto that TV based on whatever oh, that's a great idea.
That's right.
Very great. Okay. What else? What else do you have in your shop, in your office that has been really useful?
Let's see. What do we have often? Just, the model shop. We end up using a lot of the hand tools, really often. I have a Bridgeport and I have a micro mill that have gotten me out of many a pinch. The manufacturing folks listening to this will laugh at the really low utilization that those machines see. But man, when you need it and you have it and you don't have to send a part out and wait a week or two to get a modification made, it pays for itself.
Absolutely. I can think of more than one occasion where I have jumped on our mill, which is not a great mill, but it works for punching some high precision holes or slots in aluminum. And, 2 a.m, I'm out there putting some new holes in very precise locations, and hey, saved the day, delivered it on time.
Yeah. I think those capabilities, they don't look sexy in your brochure or on your website, but man, when you're shaving weeks off of a schedule because you can walk into the shop and do that, incredibly valuable.
Yeah. Your tagline on LinkedIn is, I build and lead teams that design and engineer premium hardware products for high volume manufacturing. Can you tell me a little bit more about building and leading your teams? For example, what are, I don't know, like, this sounds kind of cheesy to say it this way, but what are some of the top 2 or 3 things that you've learned about building and leading successful design and engineering teams?
Yeah, I think the first thing that comes to mind here is I'm always learning. When I'm thinking about building a team, I'm thinking about a recruiting process. I had a great opportunity at Apple to learn to interview folks and conduct technical interviews when I was at Sonos, helping build the team there. I got to practice more of the interviews around behavioral aspects and personalities, and understanding not just technical abilities, but also a lot of companies use culture fit, but it's kind of beyond culture fit. And I don't know how to articulate it because I'm not good at it yet. So interviewing and recruiting is one thing. And go ahead.
Going back to interviewing and recruiting, have there been any, go-to questions or like pro tips that you've used to interview people and pretty quickly assess whether they'll be a good fit for the team?
For sure. I like to conduct my interviews for Maestro, where we're less structured than like a Sonos or an Apple, where, we've got a panel and each person's asking their, particular questions. I like to frame up a series of technical questions that are hard enough and open-ended enough that we can have a kind of a brainstorm conceptual design discussion, and dip into some technical details. And really, I'm looking for two major things. I'm looking for a collaborative spirit. Is this candidate going to be okay in a world where they don't have all of the boundary conditions and they have to make some assumptions and they have to kind of deal with some ambiguity, and can they work their way to finding an answer? And then number two is, the technical ability. Is this candidate able to apply engineering fundamentals to solve real engineering problems?
Along those lines, what are some of the common roadblocks that you see engineering teams falling victim to?
In terms of recruiting or just in general?
No, just in general.
Mistaking activity for progress. We built a bunch of prototypes. We did a bunch of calculations. We ran a bunch of analyses.
I was busy all day.
I was busy all day. Yeah. That's probably one of the more common mistakes I see teams making.
How have you helped, or how have your teams helped each other identify when you're just being busy as opposed to productive?
It's really easy. What problem are you solving? And why does the customer care? Got it.
And if the answer to those questions is not, aligned with what it should be, then, you're just being busy.
Yeah. And every day I'll ask the team, why are we not shipping this product right now?
Nice. That's a great question to ask. Yeah.
And then there's the list. They're like, Joe, haven't you seen the MIL? Of course I've seen the MIL. Let's talk about the priorities on the MIL. Are they the same today as they were yesterday?
Can you define MIL for those who may not know what it is?
Master issues list.
Great. Okay. You've worked at a few PD service firms, and I'm curious what your take is on how to charge for this service. Time and material or fixed price?
Oh, it's all the same to me. I tell my clients it's all the same. If you have a really clear statement of work and you can clearly define the deliverables, and everyone can understand the end state really well, and you have confidence that you and your client are speaking the same language, then fixed bid, sure. That's typically works out fine in those situations. It can sort of simplify the billing and the administration. So if you care about those kinds of things in your life, then a fixed bid can help alleviate some of that back end work. When the client has trouble articulating an end state, or when you get the sense that you have a long road ahead and there's some learning to be done, then time and material starts to make sense. And I've started a few engagements that way, where clients show up, and I've had startups behave this way, and I've had giant megacorps behave this way. No, Joe, we know exactly what we want. This is the project. Your colleague Billy told me to call you, or whoever it is, how the connection's made, right? And I say, great. Where's your PRD? you said that you've already built something like this. Where's the thing that you've built already? What is it about that thing that works well? What doesn't work well? And through that discussion, I've arrived at a point where I will say things like, it sounds like I might be able to help you put some of that information into place. It's going to take enough effort and enough time that I'm not going to be able to do it all for free. I got to justify my time expenditure to the CFO. CFO is not going to let me, put in this level of effort. It's not going to cost you much, but let's start there.
Yeah. That's a good way to put it.
And then after that, will a scope of work will emerge.
Yeah. Nice. If you can think of any, what are one or two of the like boring, mundane, seems too simple to make a difference habits or routines that actually end up making a huge difference in the end and are practiced by the best engineering groups that, from the outside might seem like, wow, that's such a small, insignificant thing. Surely it can't make all that much difference.
Let's see, the small insignificant thing that I see design engineers, certainly in the product design world, sort of glossing over or deferring all the time, tolerance analysis.
Okay.
Anytime a candidate tells me, I don't do tolerance analyses till I have a drawing, or I don't know what the nominal is, I can't do a tolerance analysis, like that's a giant red flag. Or we just need to do some learning. So that's the simple thing. The big thing that's really valuable and easy to gloss over is a design review of any kind. I'll relay a conversation that I had recently with a colleague of mine who's kind of a one-man show on a kind of a complex system. And he was telling me a story where his client was looking over his shoulder and he was putting the parts together and they didn't fit. And the client's like, I thought you knew how to do this. I thought this is your thing. Why do these parts not fit? And it's, one of, God, in that build, he probably had, it was on the order of 100 custom parts.
Wow.
And they're big sheet metal, plastics, some 3D printed parts. Like it was a fairly complex system. Many moving parts. There was like a fairly large mechanism holding a really expensive, element of this particular product. This is really, really high-end stuff. And he was, we were talking about this over a beer and he was just shaking his head. He's like, I can't believe I messed up. And the bolt didn't line up with the hole in the enclosure. And I said, well, how much time did you give yourself to review that before you kicked off your parts? And he's like, well, and did you have anyone else review it for you? He's like, well, no, I didn't. I said, you have a lot of parts in that assembly, and that is a really high expectation of yourself to have everything all complete and tidy, and for all of those parts to actually fit together when they're manufactured. Oh,
absolutely. I'm surprised only one part didn't line up.
That's exactly what I told him. And so anymore, if it's me, often it is working on something, really fast, really tactical. I'll give myself an extra day to do nothing but cut cross sections and run interference checks, and then go through and nudge surfaces and, check all my gasket compressions and go through all of my tolerance analyses and make sure, like in the heat of battle, when I was in the CAD, I didn't actually change the datums around and everything still lines up. Okay, good. And then at the team level, design reviews are one of those things that are, they get to be a pain in the neck. It takes time, detract, you're not getting work done. There are all kinds of reasons to not do them. I encourage everyone to scrub their design thoroughly with their cross-functional team, certainly before kicking off tooling.
Yeah, absolutely. What is your design process like? When you're starting a new design, do you start with some sketching first and then maybe move into CAD? Do you start in the shop doing like some cardboard benchtop prototyping? How do you go about that process?
We've done all of the above. It depends on the particular thing that we're designing, and it depends on the start point, right? So if a client comes to us and they have a functional prototype and they have a CAD file, well, then that's the start point. We've done projects where the client has shown us their current product and told us about all of the problems and told us explicitly, we don't want any CAD. We just want concept sketches. So we've done entire projects where it's literally just concept sketching. Here are the parts. Here's how they could fit together. Here are the datum structures. Here how the different parts assemble in which order. And so it's really project specific. If I'm not trying to evade your question, but I would say, so most often there's some whiteboarding up front, and we'll relatively quickly jump into CAD just to kind of check our work, kind of check our sketches. And then we often start building. I mean, you ask about the process. It's kind of a look at the product holistically, and then break it apart into its, sensible sub-assemblies or sensible challenges. And then either assign engineers to the subsystems, assign engineers to the challenging elements, and get, many brains working in parallel. And depending on the particular problem, maybe it's simulation and CAD studies, maybe it's building things in a shop. Maybe it's, a tight interaction with ID where we're sending files back and forth, have some tricks to helping ID converge quickly.
Do you have any best practices as it relates to team sizes? Like, do you find that, teams of up to 4 people or 8 people or whatever it is tend to work pretty well, but beyond that point, too many people are involved, the process gets bogged down?
Yeah, that's a really good question. I've worked on small teams that are really effective and small teams that are ineffective. And I've worked on large teams that are effective and large teams that are ineffective. So I think the common thread is that each person on the team has kind of clear direction on what it is they need to be doing, and they understand sort of the higher level product goal. And they kind of have they're all shooting toward the same North Star. Okay. The problem that I've seen is when too many people start joining the team without great context, without great onboarding. Maybe they're brought on to look at a particular element of the product without the context, without that tribal knowledge.
Yeah.
Which is another hard problem. As much as I try to encourage engineers to document their work and, kind of create that really lightweight design history of how they've made the decisions they've made, it's really hard to do. And even then it's even harder to pick up. So we end up in the heat of battle building that tribal knowledge. I'm thinking back to some of those teams that were super effective. On the technology products, on the consumer products, if you've got circuit boards, connectors, a screen, antennas, that kind of a feature set. I've had a lot of success when we have a product design lead, a technical lead, and an engineering project manager. And then same story, tech lead and project manager on the electrical side, and tech lead and project manager on the software side. If you can keep those folks, really tight knit and really working well together, then they can sort of drive their, sort of their closer cross-functional partners toward that North Star.
I would love to hear your take on project management. What do you see as the role of a project manager? How do they add value to the team?
It's a great question. The best project managers help me do my job better. And the way they do that is through prioritizing the work. They help me delegate the work, and they help deconflict. So anytime there's conflict and I'm not talking interpersonal conflict, that's one thing. There's also, the electrical engineer doesn't have enough board area. That's a conflict that has to get resolved, and being able to identify those conflicts. And then the best project managers that I've worked with are actually way out in front of me, and they're building bridges. I had a project manager that I worked with at Apple, and it was incredible. I'll just describe it like one scene for you to give you some idea. I get off the plane, drive into the factory, and I show up and I set down my bag, and he called me Joe Moak. Joe Moak. The parts are on the table. FAI forms are there. I need you to review all the parts. I'm going to go talk to the electrical engineers. Their S&T schedule screwed up and getting us out of here a day early. And that was it. He left the room, and I'm like, great. Like the parts, he pre-vetted all of the inspection reports.
Wow.
All the parts were there. All the inspection forms were filled out correctly. I don't know how many he sent back because they were filled out incorrectly, but I know he did. And he came back, whatever it was, 2-3 hours later, and he says, "Are you done yet? We got to build." I said, "Yeah. Here are the ones that are approved. Here are the ones that are waived, and here are the ones that we got to fix."
Nice.
It's like, great. I'm like, "Are we getting out of here early or what?" He's like, "Yeah, we're getting out of here early." That's a great project manager.
That's awesome. So he kind of lays the groundwork for you. So when you come in, you can just do your thing. You don't have to worry about where's this thing, where's that thing. Do we have the right people here?
That was factory, and he was like that with every cross-functional team. He was, he had our back and supported. In this particular case, it was Apple, and we're just all trying to ship a great product. We're trying to make our customers happy. And he was just really good at helping us all keep our eye on that ball.
I like to define, I think what you said is very much in alignment with the definition that I like to use for a good project manager, which is someone who aggressively and proactively identifies and mitigates risk, right? All of those things.
Brilliant. Brilliant.
No, I'll take that as a huge compliment from you, Joe Moak. Thank you.
You're too kind.
All right. Well, last question for you. What are one or two of the biggest challenges that you have at work?
Oh, that's a good one. With all of the things that are going on, all of the projects that I have on deck, the bigger challenge is figuring out where I need to apply my time and my effort versus where I need to delegate. And then with that delegation comes sort of the engineering management and the people management, which, frankly, it's not my thing. Like, I ended up like building and leading teams just because, I don't know, what one of my colleagues said, "Joe, sometimes if you're the person holding the candle in the dark room, people are going to be around you."
Right.
And look to you. And I feel like I've found myself in that position through most of my career.
Yeah. Well, how can people get a hold of you, Joe?
Let's see. I check Twitter once in a while. I'm just at Joe Moak. That's probably the easiest way. My email address is joe@maestro.design. And I have a Facebook account that I check, I don't know, intermittently. I'm really terrible with the social media stuff, but the easiest way is probably email or Twitter.
All right. Well, Joe, this has been such a treat to talk to you. Thank you so much for sharing some of your time and your wisdom today. I really appreciate it.
Likewise. Thanks for having me, Aaron. It's been fun.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.